This is the second part of the video. Sorry about that. It cut off and I really couldn't do much about it. So the interpreting the graph of velocity that we're going to do, like I said, you might not have heard. Take the time to pause the video, think about this, add some notes to the side. I know it's tiny so that you've got some things to think about. They talk about the student walking in front of a motion detector, forwards and backwards, and these are her velocities graphed. So I'm going to go over to the graph right away and put that this is v of t because I want to realize these are not her positions, these are her velocities at 1 second intervals for 36 seconds. So I know this is time 36 over here, and I'll help you out. It counts by every 4 second intervals. So I'm going to label those time intervals on my x-axis just so that I can think about, or my t-axis, so I can think about those times as they relate to the graph. The minute you find out this is a velocity graph, I would suggest going over to the side. What velocity means is up here, these are speeds that she was traveling to the right. Down here, any y values are speeds she was traveling to the left. And here would be any time her speed was 0. And if you think velocity is speed with direction, positive velocities are speeds to the right, negative velocities are speeds to the left. If you want to think about it as her walking to the right or to the left or towards the motion sensor or back, so maybe instead of speeds to the right, you want to think about that going forward, speed to the left being going backwards. So then it asks you, when is she moving forwards? So she's moving forwards anytime her velocity is positive. And she's moving backwards anytime her velocity is negative. So if you look on the graph, you should be able to identify those regions when she's moving forward, because all the times on this graph when her velocities are positive, she's representing speeds that she's moving forward or to the right. So I would say about 0 to 14 on that graph, she's moving forwards for sure. Again, not inclusive. Once we get to the next part, she's going to be 32 seconds up to 36, where she also has moving forward. So then pause the video for a second. See if you can find where she's moving backwards. See if you can go down to the bottom and see when you think when she's standing still for more than an instant, and then come back. If you're back, her velocity should be negative from about 14 to 26 seconds. And when she's standing still for more than an instant, about 26 to 30 seconds, when her velocity is 0. She's not standing still from 4 to 8 seconds where you have a flat part to that graph because her velocity there isn't 0. So then they want to know where she's speeding up or slowing down. So when you think about that, any velocity that's farther from 0, as you get farther from 0, so if I'm moving away from 0 speed, I'm getting faster. So as I'm moving away from 0 speed, I'd be speeding up. And as she's moving closer to 0 speed, she's slowing down. So from 0 to about 4 seconds, she is definitely speeding up. Then she's not speeding up anymore. She's going at a nice constant speed. And then her speed comes back towards 0. So now she's slowing down. So she's speeding up here. She's slowing down here. Now, when we get here, she goes in the opposite direction, but her speeds are moving away from 0. So she is actually speeding up right there. Then her speeds, velocities, are moving back towards 0, so she's slowing down. She goes at constant rate for a little while, and then her speeds or velocities move away from 0, so she's speeding up. So pause the video and put in your intervals of speeding up and slowing down. Then they want to know when her acceleration is positive. So her acceleration is the rate of change of velocity. So they're asking you when her slopes are positive, when the slopes of velocity are negative, when the slopes of velocity is 0. So they're actually asking you about slopes or rates of change of your velocity graph. So as you're looking at your velocity graph now for slopes, again, I want to get all this stuff off there then about speeds, because again, different. So I'm looking at my velocity graph for slopes. I have positive slope from about 0 to 4. I have positive slope again on my graph from right here to about right here. And then I have positive slope on my graph there. Does not mean that in all those regions I was speeding up. It means my acceleration was positive. The slope of my velocity was positive. So my acceleration was positive from about 0 to 4 seconds. from about 20 to 26 seconds. And again, from about 32 to 36. And pause this and actually look closely to see what the differences are. Negative acceleration, so that means the slope of my velocity is negative. So I'm looking at negative slopes in here, and then again, all the way down to here. And I don't see any other regions of negative slope, so from about 8 to 20 seconds, there'd be negative acceleration. And a zero acceleration, there is zero acceleration. When our rate of change, our slope is zero, so from about 4 to 8 seconds there. And again, from about 26 to 32 seconds, roughly on that graph. And the last one, they want to know when she moves at the greatest speed. So the greatest speed, and speed is the absolute value of velocity. So if speed is the absolute value of velocity, we want to know when she's the farthest from the x-axis. And she appears to be the farthest from the x-axis right about there. So we'd be looking at about 20 seconds. So when does she move at about her greatest speed? At about 20 seconds, because her velocity is to the left, but it's still the largest y value we have in there, that absolute value of velocity. So you can stop the video now, catch up on notes, and that's all you need to do. We'll see you tomorrow.